Hey guys, so my name's Yuli Araya and today I'll be presenting my pentagram project demo. This is a AI-based web app that lets users generate images, and a product like this will usually be useful to students, everyday AI users, and people that use PowerPoint, Google Slides, etc. to present or showcase visual images. What's special about this project is that instead of using existing image generation APIs, I hosted my own image generation model myself using a serverless GPU to ensure low latency for a smooth user experience. I use Modal and Fast API for my server, and for my front end, I used API routes in Next.js, usually JavaScript, HTML, and CSS. So the user sends a query which goes through the API route, and the API route sends the query to Modal and Fast API, which uses the Stable Diffusion model of my choice to generate an image. And then it sends it back to the API route, which saves it to Vercel as a blob and also sends it to the user. One of the hardest things I had to do for this project was improving the speed and latency issues of the image generator. And through what I did to fix that was a lot of research. And I learned that in serverless architecture, functions that haven't been called recently may undergo a cold start, which was my issue here, where the functions needed to load into memory before execution. So this process, without mitigation, could lead to inconsistent performance, especially noticeable during like periods of infrequent but also sudden demand of your web app. So to fix this, what I configured was a cron job, which is I set up cron jobs to hit the image generation endpoint at a regular interval, which of 5 minutes, thus keeping the function active, and also a modal configuration, which I utilized modal scheduling capabilities to automate these calls without manual intervention. So the technical setup included creating simple endpoints within your application that serve a dual purpose of that do health checks and can trigger a lightweight generation task that doesn't require substantial computation, but is sufficient to keep the model loaded. As you can see through my strategies, I was able to bring it down from an execution time of approximately 10 seconds to 5 milliseconds. And it doesn't lag, it doesn't cause any latency issues, as you can see.